Hello everyone, and welcome to the 16th video in the TypeScript tutorial series. Today what we're going to do is we are actually going to introduce animated sprites. And if you recall last time, we actually added behaviors and we have our sprites already and we have our behaviors acting on our sprites. And that's actually what's causing this to rotate around, and that's great. But what if we wanted the texture itself to actually be animated? How would we go about doing that? And so that's what we're going to tackle today. And so just to illustrate a little bit of what I mean, let's say that we've got this image that has 3 frames for an animation. So if you look at this first frame here, this is 1 frame of the animation. So this has a sort of 8-bit duck with his wings down. He's flying and his wings are in the down position. And then our next frame of animation is here, where his wings are sort of in a middle position. And then the last frame, of course, his wings are in an up position, and you can see he's moved around a little bit. And so what we're going to be doing is introducing a system to allow us to animate this first frame to the second frame to the third frame and then back. And it's just basically going to go back and forth through this sprite. And so to do that, there are going to be several things that we actually need to add to our system to make this happen. And so what I've done is I've actually added this asset here to our textures folder. And so this will allow us to go ahead and load that up without having to worry about what image we're going to use as an example. This image will be checked in along with the source on the GitHub repo. So I encourage you, if you're following along, to go ahead and download that latest copy of the repo, and this image will be in this folder here. So there's a couple things that we're going to need to add to the engine to actually support this. So first off, one of the things that I want to do is make a couple of modifications to some things that we've already got going on in the engine that makes it a little bit easier to use. So it was called out by one of the viewers that you have to pass in a hard-coded size here, and we're keeping track of what this offset should be, and really those things should be handled automatically within the GL buffer class, and I totally agree with that. This was sort of an oversight on my part, so I'm going to go ahead and change that first. And so I'm going to go ahead to the GL buffer class, and I'm going to remove element size from the constructor, as well as the comment here. And I'm going to default this.elementSize to 0. Okay? And what I'm going to do instead is, in attribute location, when I push the attribute location, I'm going to increase the size, the element size of the buffer at that point. So I can say this.elementSize plus equals info.size. And so every time we add an attribute location, we're going to automatically increase the element size. Okay, so the next thing we're going to have to do, obviously, is go back to the class that's using it, which is going to be sprite. And I'm going to remove the 5 from the constructor call, because now we don't need that anymore. Great. So the next thing that we're going to have to set up is the offset. And what we're going to need to do here is basically keep a running tally of the sizes of all of the attributes that we've added, and that will tell us the offset amount. So back in GL buffer, what we're going to do is we're going to create a new variable in GL buffer, and I'm going to call that private, and we're going to call this total offset. It's going to be of type number, and it's going to start off equaling 0. Okay, and now back in our add attribute location, what we're actually going to do is we're going to edit the info before we actually push the attribute in. So we're going to say info.offset equals this.total offset. So when we pass the info object, we are updating the offset at that point. And so immediately after that, we're going to say this.total offset plus equals info.size. Okay? And so that is going to basically make sure that these offsets are always correct. So again, back in Sprite, what I'm actually going to do is remove the setting of the offset, since that gets added automatically. And so as you can see, this already makes this a lot easier to use. So I'm actually going to rebuild the application just to make sure I didn't mess anything up, and run. Okay, and it looks like I did mess something up, so let's have a look and see what that is. Oh, I'll bet I know what it is. I'll bet this needs to be defaulted to 0. Okay, let's go ahead and run. Nope, that wasn't it. Technically speaking, I think I could just use element size instead of tracking total offset, because I'm doing the same operation here. Technically, I should probably just use element size here. I don't think that's actually going to fix anything, because that's the same. So let me see. The element size. Ah, okay. I see what the problem is going to be. So in the constructor, we actually are immediately using the element size here to calculate the stride. And that's actually not going to work, because we're going to need to recalculate the stride whenever we update the element size. So I'm actually going to cut this piece of code from here, and I'm going to go to add attribute location and paste it there. So that way we can just recalculate that at that point. So just rebuild that and run. There we go. That fixed it. Okay, so it's been simplified. It's a lot more dynamic and a lot less error prone this way. So I just wanted to fix that really quickly before we move on. One other thing that I want to fix really quickly is actually in texture. So in texture, we need to make a small modification to the texture filtering. So right now, we're actually only doing the min filter, and we're setting it to linear if the texture is not a power of 2. And technically what we want to be doing is we always want to be setting this. So I'm actually going to take this line of code, this last one here, where we're setting the min filter to linear, and I'm going to cut that and paste it below. So it's outside of this if block. And so what this basically means is that this is always going to be applied. Now, the game that we're going to be making, without revealing sort of too much ahead of time, the game that we're going to be making is in a sort of 8-bit style. And so I'm actually going to set a property here that will help us mimic the 8-bit style. And this is something that probably should be a configuration option. So I'm actually going to put a to-do in here. And set texture filtering based on configuration. But what we're basically going to need to do is change this last property from gl.linear to gl.nearest. And that's going to give us that sort of pixelated look to our textures. So what it basically means is it's going to get the value to of the pixel that's nearest to its location, and it's not going to linearly interpolate that value. So in other words, it's not going to sort of try and smooth that value out. It's just going to use the straight up value, which is ultimately what gives us that pixelated look, which is actually what we're going to want. So one more thing is I'm actually going to duplicate this line of code and change texture min filter to texture mag filter, and also set it to nearest. And so this just means that when the texture is magnified, this is the sort of formula that's used to perform that operation. And so I want both of those things set to nearest always. So I just needed to go ahead and make that adjustment, and I put this to do here because it really should be a configuration option, but I don't necessarily want to go into that right now. So let me just rebuild this and run it. Okay, and it's kind of actually hard to see with what we have here, so I'm going to make a couple of adjustments to make this a little easier to see. So I'm actually going to go into the engine and just change up the color of our material. Right now we've got that sort of bluish color. We know that material tints work, so I'm just going to say color dot white. Okay. And one other thing I'm going to do is actually in the configuration for that level, the parent object, I'm just going to increase its scale so that you guys can see what I'm talking about. So I'm going to set up the scale, and this is a vector 2, so it's almost exactly the same as our position. We're basically just going to set the scale in the x and y axis. So in this case, I'm actually going to set the scale to something extreme. I'm going to set it to 8, and same thing for the y-axis. I'm going to set that to 8. I'm going to save that, and I'm just going to rebuild this real quick and run. Okay, and you'll notice that some of the changes didn't take place. The material change took place because that's in code, but the scale didn't, so I just have to force reload this by hitting Control F5. And so now what you guys may notice is that the texture is no longer smoothed out. You can sort of see the pixels of that texture when you look really closely. It's a little less obvious because it's rotating around, but that's what's happening there. So if I wanted to make it really, really obvious, I could increase the size of the texture even further. I'm sorry, the scale. So let's set this to, let's say, 32. Reload that. And now it's very obvious the effect that we're going for here. So if this was set to linear, this would be smoothed out. But since it's set to nearest, which stands for nearest neighbor, you guys can look that up if you want more details on that. You get this pixelated look, which is actually what we're going to want. So if that doesn't make sense to you, I'd be more than happy to answer some questions about that in the comments. But let's go ahead and move on. So first thing I'm going to do is I'm actually going to get rid of this scale because I just want that to be set back to normal for now. And the next thing we're going to have to do to add support for textures, animated sprites, is we're actually going to have to modify GL buffer a little bit more. So right now we actually have a method in here called pushback data, and this is great. What we can do is we're able to add data to this, but we're not really able to sort of replace the data that's there. Now, we could clear this out by adding a call to clear it, and actually I think that's a good idea. Let's go ahead and just add that real quick. So we'll say public clear data, return type void. And we're going to say this dot data dot length equals 0. And all that's going to do is that's basically just going to clear out the array so that there's no data there whatsoever. And I'm just going to go ahead and add a comment here. Clears out all data in this buffer. Okay, so the next thing that we should do is we should add a sort of convenience method that sort of does both of these things in one step. So I'm actually going to add a public method called setData, and it's going to take in a parameter called data, which is a number array. It's going to return type void. And this is actually going to be really simple. It's literally going to be a shortcut to these two methods here. So we're going to call this .clearData. And we're going to call this .pushbackData and pass it data. And that's it. So our comment will just say replaces the current data in this buffer with the provided data, the data to be loaded in this buffer. Great. And so what we'll need to do is, in order to actually update the data in the buffer, we are going to call setData, and then we're just going to call upload again. And that is all that we should have to do to actually support this. So you may have asked, what's the reason that we need to update the buffer? And the reason that we need to update the buffer becomes a little bit clearer when we look back at our sprite. So if you remember when I was talking about we have 3 frames here, the way that we're going to display one frame at a time is we're actually going to edit the UV coordinates that are being used for the given frame. So in other words, we're basically, if you consider our UV coordinates are from 0 to 1 this way and 0 to 1 this way. Right now our sprite just says 0 to 1, 0 to 1, which means it uses the whole image. What we're going to do is we're basically going to say, or we're going to calculate basically, mathematically, the UV coordinates for this. So this particular frame will be 0 to right around 0.3, and then 0 to 1. And then this one will wind up ultimately being 0.3 to about 0.6, and then 0 to 1. And then, as you may have guessed, this one will be 0.66 to 1, and then 0 to 1. And so editing the UV coordinates in real time is actually how we're going to accomplish this. So in order to do that, we needed a way to first clear out our data and then push back new data, or simply just set data. So we have those things now. Okay, so there's a couple ways that we could go about this. We could add the ability to animate to our sprite itself, which is sort of valid, but it's actually not the direction I'm going to go with this. What we're actually going to do instead is we are going to extend the sprite class to an animated sprite class and override the functionality that we actually require from this class to our new class in order to get the functionality that we need. So to do that, first thing I'm going to do is right-click Graphics, add a new TypeScript file, and I'm going to call this Animated Sprite. Okay, and basically what I'm going to wind up doing is I think I'm actually just going to copy this entire sprite class and just remove what I don't need. And just paste it in Animated Sprite. And I'm just going to rename it to Animated Sprite. And what we're going to say here is actually, after the class definition, we're going to say extends sprite. And we need to make a couple of modifications to sprite itself to support this class being extended. And basically that's going to entail changing all these privates to protected. And in case you're wondering how I did this column select in Visual Studio, if you press the Alt key and drag down over multiple lines, you will actually select in a column so that you can just type like that. So we're just going to change these privates to protected so that our newly inherited class has access to them. And I don't think there's any private methods here. No, there's not. Okay. So back in Animated Sprite, I'm going to delete these privates because I don't need them. And our constructor is bleating at us big time because it's wondering, hey guy, what are you trying to do here? You're inheriting from a class, but you're not calling super. So the first thing we need to do is call super and pass name, material name, width, and height. Okay, and then we can add some properties and additional logic right here afterwards. Next thing I'm going to do is get rid of name, because our base class gives us that. I think I can go ahead and get rid of destroy. You know what, I'm not going to get rid of it right now. I'm just going to leave it blank and call super.destroy. Just in case there's something I need to destroy after that, I can go ahead and clean that up. Let's see. Okay, so my draw logic actually is not going to be changing, so I can delete the draw method. And update, I need to say super.update, past time, just in case we add something to our super update class that doesn't get missed. Okay. That should be everything that we have to do. We're going to mess with this in a minute. Let's see. I'm actually going to make another modification to the sprite base class here, just to make our lives a little bit easier so we don't have all this duplicated logic in Animated Sprite. So I'm going to go back to sprite, and right now we're just creating a local variable called vertices and pushing it back directly. We actually want to keep a copy of this. So I'm actually going to say at the top here, protected underscore vertices, and it's going to be a number array equals blank array. And then I'm going to say, instead of let vertices, I'm going to say this dot underscore vertices, and I'm going to pass this underscore vertices to buffer.pushbackData. So that way it keeps a copy of everything that we initially load. And yeah, that should be actually all we need to do as far as that's concerned. Okay, so back over in Animated Sprite, what that allows us to do here is actually say super.load, and then we can define some other logic here. Okay, so what this class is going to need that's different from the sprite is it's actually going to need information about these individual frames of animation. Okay, so right now what we're actually passing in the constructor is a width and a height, and we need to pass some additional information in order to get the frames. So we actually need to pass a frame width and a frame height, and that will give us this, for example. And the way that this is going to work is we're going to calculate our frames dynamically as far as their position in the texture goes, so that we can modify the UV coordinates appropriately later on. And so we're going to pass a frame width, a frame height, and to make things simpler, we're actually going to pass the total number of frames that we have. And then we should probably pass the frame order that we want to be played, or the frame sequence rather. So that will allow us to actually say frame 1, frame 2, frame 3, frame 2, frame 1, 2, 3, 2, and etc. to get it to move back and forth. Okay, that was a lot. So let's go ahead and add that. So we'll say frame width number. In this case, we'll say equals 10 by default. Frame height number equals 10. We'll say frame count number equals, let's default it to 1. And then we'll say frame sequence is a number array. And we'll default that to an empty array. Okay, this constructor is actually quite long, so we might want to consider switching this to some sort of configuration class. I'm not going to do that just yet, but I think I am going to switch this over to being a configuration class, because that's getting quite long. But anyway, so to hold these, we're going to need a few private properties. So we need a private underscore frame height, which is a number, private underscore frame width, which is a number, private frame count, which is a number, and finally frame sequence, which is a number. Number array, rather. And we're going to default that to an empty array. Actually, we don't need to do that because our constructor is going to provide that for us. The other thing we're going to want to do is we're going to want to add a private, we'll call this current frame, and it'll be a number, and we're actually going to default that to 0. So this is going to be what tracks the current frame that we're on. And I'm going to add another private property, which should be configurable, and we'll probably add this to configuration. But we'll say frame time, and we'll set this to, well, it's a number. Set it to 300 for now, or let me think. Set it to 333. So that's going to wind up being the milliseconds that each frame lasts. So we want to play 3 frames a second by default. So to do, make this configurable. Let's move this up here with the rest of the frame properties. Okay. So now we can say this dot frame width equals frame width. This dot frame height equals frame height. This dot frame count equals frame count. This dot frame sequence equals frame sequence. Okay. So now we've got those properties saved off. So at this point we need to set up a couple of things. Okay, so at this point we actually need to set up some frame UVs. So we actually need another property. Let's go ahead and create a variable also to hold our UVs. So we're going to call this private underscore frame UVs. And this is going to be it's going to be an array of vector 2s. And so as we calculate our UVs for our frames, we're actually going to store them here. And this actually makes me think that we need to make one more modification to our sprite class. So right now, our vertex information or vertex information is stored as a numeric array directly, which is technically it's lightweight, it's somewhat easy to understand, but it's not as easy to modify from a code perspective. And so I really think that it's time that we come up with a sort of a container, an official type of container to hold positional data as well as UV data, so we don't have it in a numeric array like this. So under graphics, under graphics, we'll add a new TypeScript file, and we're going to call this Vertex. Okay, and we're going to put this under namespace TSE, and we're going to export class Vertex. Okay, and this is going to represent the data for a single vertex. And it's simply going to hold a couple of properties. So there's going to be a public position, and it's going to be a vector 3. Let's go ahead and default this to vector3.0. There's also going to be a public text chords, and that's going to be a vector 3. And let's also default that to vector3.0. Okay? So now we have this very simple vertex class that just holds these values in a container for us. One more thing that we're going to need to do is we need a couple of convenience methods here. So we're going to say public to array, and that's going to return type number array. And what that's going to do, let's see, let's go ahead and say let array number array equals new array. We're going to return array. What we're going to do is we're going to say array dot concat, and we're going to say let's see, position dot to array. Okay, and actually I need to say array equals array dot concat. So I'm basically just going to do this both for position and text chords, and then we'll return that array. And let's also make a public to float 32 array. I don't think we're actually going to need this, but just in case we do, we'll have it. New float 32 array, this.to array. Great. So I'll just fill this out with comments later. So back in Animated Sprite, back in Sprite, we actually want to change our vertices to an array of vertexes. And you know what? Let's add a constructor to vertex just to make this a little bit easier. So we'll say public constructor. And I'm actually going to add numbers. So I'm going to say x number y number, z number, and then tu number, tv number. And we can set both these to, we'll set the texture coordinates to 0 by default, just in case they're not. In fact, maybe we'll set them all to 0 by default, just in case at some point we want that convenience. Okay, and now we can say this.position yeah, we'll just do it this way. This.positioning x equals x, and I'm just going to copy this for y and z, y and z. And then I'll say this.textChords.x. Oops, text chords should be a vector 2, not a vector 3. Make sure to fix that. Equals tu. This.textChords.y equals tv. There we go. Just make sure that works. Really? Vector 2 doesn't have a 0? Huh. Okay. Let's go ahead and add that then. So vector 3 has a .0, but vector 2 does not have it. For some reason I forgot to add that. So what I'm actually going to do is I'm going to copy these definitions from vector 3 and go to vector 2. And right here, I'm just going to change these to, say, vector 2 and vector 2, and remove the z element for that one. Okay. Now it should be good. Okay. So now back in Sprite, obviously this is going to be bleating that we have an error here. So I'm going to use my column select trick again and just select that sort of first space for these 3 lines. And I'm going to say new vertex open parenthesis. And then before the last comma, I'm going to close the parenthesis on each one of these lines. Because these properties happen to already be in the correct order that we need them for this object. So I can do the same thing with the last 3. So I can say new vertex open parenthesis and just close before the last comma on each one of those. Okay. And now our pushback data, we set, instead of just passing this.vertices, we say this.vertices dot So I have the ability to set all of these. Okay, this is going to have to change slightly. Because basically we can't push this all as one collection anymore. We just need to push them individually. So let's just say for let I, actually we'll say let v of this.vertices, and now we can say in here v dot toArray. Right, and it'll just push that data back. So this just makes things a lot cleaner for us to work with and deal with, and will also give us the ability to modify these vertices for our animated sprite. Okay, so with all of that out of the way, the next thing that we need to do is we need to calculate our frame UVs. And the way that we're going to do that is, I think it's best to just go ahead and calculate that in the load method. I don't really think there's any value to doing it in the constructor. Alright, so to calculate this, what we're going to need to do first is figure out how many rows we actually have in our image. So it's also possible that we'd have an image that would say have 2 sprites here, or 2 frames on this row, and then there might be another row here that has another 2, and another row that has another 2, and whatnot. So based on the total number of frames that we have, we need to figure out how many of these frames are on each row. Okay, so what we're going to do is we're going to say for let I equals 0, I is less than this dot frame count plus plus I. Okay, so we're going to say for each frame. And we're basically going to keep a running tally. So let's say up here we'll create a new variable. We'll say let total width equal to 0. Okay? And then within our for loop we can say total width plus equals I times this dot frame width. Right? So every time we increment a frame, we are going to keep track of where we are in the image. And then we'll say if total width is greater than this dot width, then we actually need to increment our y-axis to move down a row. So up here we'll just say let y-axis, let's call it y value, equals 0. So here we can just say y value plus plus. Okay, and that will increment that for the next the loop. Okay, and then also if this happens, we want to say total width equals 0. We want to reset that. Okay, so next is actually calculating the u and the v. So let u equals total width. Nope, not total width, sorry. So let u equal I times frame width. Okay? And so that's actually going to give us the pixel value. And remember, what we want is that we want the 0 to 1 value. So we actually have to normalize this to that. So once we have the position, then we need to say where in the width of the image is that. So we just divide by this dot width to get that number. Alright, then we'll say let v equals y value times this dot frame height. Okay, and then again we want to normalize that to the image's size, so we'll say this dot height. I believe that is all we should need to do for the UV coordinates, except push them to the array, so we can say this dot u frame UVs dot push, and we'll say new vector2 UV. Okay, so now we have those things stored. Alright, now during our update routine, before we call super update, what we're going to do is we're going to track to see what frame we're currently on. So if you recall, we stated that our current frame is going to start at 0 and our frame time is 333. So we actually need another variable here, create a private current time, number equals 0. So down in our update, we'll say this dot current time plus equals time, right? So that's going to add the milliseconds from since the last update to our current time. And now we can say if this dot current time is greater than this dot frame time, then the first thing that we do is increment the current frame, right? So this dot current frame plus plus, and then reset this dot current time to 0. Okay? So now that we have incremented our current frame, we need to check it to make sure that it is not outside the bounds of our array of our frame sequence. So if this dot current frame is greater than or equal to this dot frame sequence dot length, then we want to reset this to this current frame to 0. Okay? And so this way our frame here will never exceed the length of our frame sequence. Alright, and since in here we've performed an update, since we've actually changed a frame, this is where we're going to want to update our vertex data. And we're only going to want to do this when we change our animation data, or change where our frame actually is being updated. So we wouldn't want to always do it here for every single frame, because that wouldn't be efficient. We only want to update this data when it actually needs to be updated. So what we can do is say this dot, actually I'm going to have to, just for the sake of keeping all this stuff straight, I'm going to temporarily copy this update procedure, or this vertex loading code from Sprite. And so what we're going to need to do is replace the UVs of all these guys with the proper ones. Okay. So I just realized I actually had a minor oversight with this. I don't actually have enough UV information being stored here. So I actually need a min and a max UV, which is what I have here. And currently I'm only storing the min. And what I mean by that is in our sprite, we basically are saying we need the texture from here to here and from here to here. But right now I've actually only stored this information. So I actually need to store off this information as well. So our UVs, our frame UVs array that we have here, is actually not quite enough information. We actually need our min and max UVs. And so I think the easiest way to store this is we're going to create another class in our animated sprite. Whoops, I just realized this is called Animated Sprite. Let me get rid of that. We're going to create another class here. We're not going to export it because only this class is going to use it for now. But let's call this UV info. And it's going to have a public min, which is a vector 2. And, whoops, and a public max, which is also a vector 2. Okay, and let's just create a constructor, min, vector 2, max, vector 2, this, caps lock, this dot min equals min, this dot max equals max. Okay. And our UVs, our frame UVs, are actually going to be an array of UV info. And so before we can actually push this, we're actually going to have to say let min, which is a vector2, equal new vector2, u and v. And now we actually need to create our max, which is going to be almost the same code but not quite. So I'm actually going to copy this and just paste it below and get rid of the lets for the first two lines. Change this to max. And so now I'm going to say our u, actually, you know what? Let's call this umax and vmax, just to make this a little bit more clear. So the only difference here is once we actually have this value, we need to add frame width before we divide it by this .width. So that's basically saying, it's the same as saying, okay, we have this, now add the width of this to get that. And then we'll have this, add the height to get this height down here. And so it's just a small extra step, but it's an extra step that's absolutely necessary. So let's just add that here. Okay, and then umax, vmax. Okay, and we're going to say new UV info, and we're going to say min and max. Okay, so that should have all the info that we need. So now we have our min UVs and our max UVs. So down here, back to this update again. We want to update these vertices sort of in this order, right? So this is basically minimum, 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 maximum, max, 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 min, and then min, min. So we are actually going to update this in the same way. So we're going to say this.vertices, and we're just going to go in order here. So we're going to say 0, and we're going to say text coords, and we really need a copy from. I'm going to make one modification to vector2 to make our lives a little bit easier. I'm going to open this back up, and I'm actually going to create a new method here called copy from, and it's going to take in v, which is the vector2. It's going to return type void, and it's going to say this.x equals v.x. This._y equals v._y. And what that will allow us to do is very easily say text coords copy from this dot frame UVs, same index 0, and we can then say min. Okay? So this allows us to say basically just copy your values from this one to this one. Alright. So that's actually not going to be quite correct. So actually this one should be this dot frame sequence, this dot current frame. Right, okay. So just to make this code a little bit clearer, I'm actually just going to extract this code here and say let frame UVs equal this frame sequence for this current frame. So it's basically saying which frames UVs should I be pulling for the current frame within the frame sequence. Okay, and then I can just use that number as the index here. So down here, so this one I can copy directly. The next one I'm not going to be able to copy directly because it's not just using the minimum, it's using a mixture of the two. So vertices 1, and then we'll say frame UVs min. What we're going to have to actually do here is say new vector 2. We're going to have to say frame UVs dot min.x, but for the y we actually need the max, so we're going to say comma this dot frame UVs dot max dot y. Okay, and for this we actually don't need the copy from, we should just be setting this one equal to new vector 2. Okay, so for this one we want the min x coordinate and the max y coordinate, which matches up with what we have here. Okay, so for the next two we can simply copy from the max. So the next two lines are very simple. I'm actually just going to copy this first line here, and I'm going to paste it twice, change this to 2, change this to 3, and change both of these to max. Okay? Because we have 1.0, 1.0, 1.0, 1.0. So those are just simple copies of the max. The next one is going to be, again, be a mixture, so I'm actually going to copy this second line, and I'm going to paste it, and I'm going to change the index to 4. But instead we have the opposite situation here. So we have max and then minimum. So I'm just going to change this to max.x and min.y. Okay, and the last vertex is actually the same as the first, so I can copy this line, paste it here, and there we go. So our UV updates are done. We can actually get rid of this code, because that was just there for reference. And so anytime we make a frame change, we are updating the UVs. And aside from that, that really should be all. Nope, it's not all we need to do. There's one more thing. We need to actually update the buffer. So we need to say this dot buffer dot set data. Funny enough, our set data actually isn't going to work because it expects a long number array. So what I'm actually going to do is go to sprite, and I'm going to copy this bit of code here that has this loop. So we can basically say for each of these vertices, just push back the data of it. But before that line of code, we need to say this dot buffer dot clear data. So you can see now why I wanted those things separate, because they don't always necessarily make sense from every perspective. So we clear out the data, and then we go ahead and set our data here. And that should be all that we have to really do. Nope. Upload and unbind. We actually need to tell it to upload the buffer data. Otherwise, we're not going to see any changes. Okay, so just to recap, because there's a lot going on here. In our update loop, we add our current time. We add the frame time to the current time. We say if our current time is beyond what our defined frame time is, which is 333 milliseconds. Then we go ahead and increment the current frame. We also reset current time to 0. We also check to see if we are beyond the bounds of the frame sequence array. If we are, we reset the current frame to 0 there. We grab our frame UV's index from this frame sequence and then current frame. This is how this is used. So we're basically saying if we have a frame sequence of, let's say, in our case it's going to be 0, 1, 2, and we want to go back to 1, right? So that's going to be our frame sequence. So our current frame will actually be the element of this. So if it's 0, it'll be 0. If it's 1, it'll be 1. If it's 2, it'll be 2. If it's 3, it'll be 1. So just to make that clear how that's used. Okay, and then we're going through here and updating our texture coordinates, clearing our buffer data, pushing back our new buffer data, uploading the buffer, and then unbinding it. All the rest of the code should be about the same. I believe that's actually all we need to do here. So in our configuration, we're actually going to want to declare in our components some of the stuff that we want to actually create here. So let's see. Alright, so what we're actually going to need is a new material. So I'm just going to register a new material. I'm just going to copy this one, and I'm going to rename this new one duck. And I'm going to change the asset to be, what did I call that? Duck.png. Okay, and the rest of that is fine as far as that's concerned. Okay, the next thing that we're actually going to have to do is, if you recall before, we actually wrapped our sprite in a component. And so we're actually going to need to create a, basically almost a duplicate of the sprite component, but it's going to have to be for the animated sprite component. So I'm actually just going to copy this entire file, and under components, I'm going to say add TypeScript file, and I'm going to call this animated sprite component. Okay, I'm just going to paste this and put the word animated before all these classes. Right there, right there, right there. Basically anywhere where there's sprite component X, we're just putting animated in front of it. Okay. So the next thing that we can do is we can actually inherit from our sprite component somewhat as far as some of this stuff is concerned. So for example, the animated sprite component data can derive these two properties from that. So after animated sprite data, we're going to say extends sprite component data, which allows us to get rid of these properties. And we can get rid of these two checks and just call super.setFromJSON. Right, and then we get those things for free. Now, we'll need to be adding some additional properties to this. We'll need to add a public frame width. It's going to be a number. Public frame height. It's also going to be a number. Public frame count, which is going to be a number. And what else? Frame sequence, that's right. Public frame sequence, which is a number array. and I'm just going to default that to a blank array. Okay, so in here, I'm going to say we're actually going to require all these properties in configuration. So in our data, all these things are going to be throw errors if we don't have them. So we're going to use the same name. So JSON dot framewidth equals undefined. Throw new error. Animated sprite component data requires frame width to be defined. Okay. And then I'll say else this dot frame width equals, cast it to a number, and then we'll say JSON dot frame width. Okay, and I'm actually going to copy this block of code 2 more times for right now. And I'm going to change this one to frame height, and this one to frame count. Okay, and then lastly I need one for frame sequence. So I'm going to copy this one more time, say frame sequence, except I'm going to get rid of the number constructor and just take it in as is. And so this needs to be a number array in the JSON configuration. Oops, change this error message to frame sequence. So in our animated sprite component data, we should have these properties present. If any of them are not present, an error will be thrown. Okay. So in our builder, we're going to say animated sprite, and we've already switched those classes over, so that's all that should need to be done there. In our animated sprite component, this needs to be changed to animated sprite. We already have our component data. Let's see. Okay. So here's where I can actually get some of those other properties from. So I'm going to say data.width. Ooh, I don't have width here, do I? Shoot. Okay. Need to add 2 more properties here. So I need public, say image width. Should that be? Yeah, that's fine for now. Public, I'll say image height, number. These things are going to be required too, so I'm actually just going to copy these 2 and paste them above. Image width and image height. Sprite didn't require these things, but we actually have to know this information for our animated sprite in order to be able to calculate things correctly. So, let's say data.image width, data.image height, data.frame width, data.frame height, data.frame count, data. Frame sequence. So as you can see from the amount of properties here, I think it would be a good idea, again, to switch this over to a some sort of configuration struct of some kind. But for now, I'm going to leave that as is. And this is actually missing a update loop. So I'm going to say public update time number, return type void. Oops. Super.update. Always make sure that's called. Okay. But I want to say this.sprite.update time. Again, the regular sprite didn't require an update call, but this one does, so we need to add it. And that should be it. We're already registering here, so we should be good to actually go ahead and add some configuration. So back here, I'm actually going to create a new object. Let's create it up here. Okay, and I'm going to name this one duck, and its transform is going to be, set its position, let's go ahead and set that to 300. Oops. Let's go ahead and set its components array. So under its components, there is going to be one component. Its name is going to be duck component, duck animated sprite. And its type is going to be animated sprite. And just for reference, I've got these other properties from our component data copied. So temporarily I'm just going to paste those in here. I know they don't make any sense as far as the JSON is concerned, but just makes things real easy to set up for me. So let's say image width, and in this case, what is our image width? What are our actual dimensions here? 51 by 12. That's interesting. Why is it 51 pixels? Oh, because it's probably 17 pixels across. Okay. Yeah, 17 by 12 is our sprite size. Okay. So 51 is our image width. Image height is 12. Frame width 17. Let's see, frame height is 12. Frame count is 3. Yeah. The frame sequence is an array of numbers, which, if you recall as discussed, it's 0, 1, 2, 1. And then it just loops. Okay, so I'm going to get rid of this reference code there. Okay, so now we have our animated sprite configured. So that should be everything that is required. I'm going to go ahead and rebuild this. Oops. Sprite component data used before its declaration. Oh, it probably needs a reference. base component to use before. Okay, so that needs a component to that. Sprite component. Wow, this one needs it now? That's weird. Okay. Sprite used before its declaration. So this also in graphics needs a reference to that. Okay. Let's run. Let's force reload. Looks like we might have an error on our hands here. Cannot read property tint of undefined. What did I mess up here? Oh, I forgot the material name. Change that to duck. Okay. And it looks like, let me move that out of the way. Oh, I just happened to choose the same position as that. Let me change this to 100 and 100. So for some reason, it's not animating, which is odd. And it also looks like some of our data is actually wrong as well. Let's take a look at Animated Sprites. Actually, oh, because this width and height are actually used in the Vertex data, this is actually going to be incorrect. That's because I'm using width and height incorrectly. Okay. I wasn't sure if this was going to work the way that I initially planned it, so I need to actually add a couple properties here. So I can't use width and height as the actual to figure out the image size, because that's not actually correct. What I need to use is this .material diffuse texture .width. And since that's kind of long, I'm actually going to save that as a local variable. Text width equals that. Text height okay, and I'm actually just going to divide by the texture width and the texture height. Okay. And in the configuration, we need to update actually our data. So it's actually going to have to be done in the sprite component. So, So this shouldn't be called image width. This actually needs to be just called width. And this just needs to be called height. So let's just change this all to width and this all to height. And height, width. Okay. So now we're actually defining the width of the sprite. the width and the height of the sprite, rather. Which should be the same as, technically the same as the frame width and height. In fact, we might just use these instead. You know what? Let me get rid of width and height, because these are actually going to be wrong. So I'm going to get rid of those and use the frame width and the frame height as the actual height. So in Animated Sprite, component, I'm actually just going to, instead of passing width and height, I'm actually just going to pass frame width and frame height again for those things. Remove these properties from here, remove these properties from here, and I'll just have it pass through the frame width and the frame height, because that is ultimately going to be what we want to use anyway. I may want to override that at another point, but for now it should be fine. So go ahead and rebuild that. Okay, so now it's not animating, and it's a little bit small because of the resolution of the image. So first thing I'm actually going to do is I'm actually going to copy this position, change it to scale, and then let's scale it up by 8 times. Alright, so the next deal is to figure out why the update isn't actually being called in this. So let me look at, whoops, so let me look at SimObject and its update call. So it is updating the components. The sprite update is an animated sprite. So its update call is being done here. Temporarily, I'm just going to output the current time to the log, just so I can see what's getting passed there in that update call. We're passing zeros. No wonder it isn't working. Okay, so we've got a bug somewhere in our update call, and I have a feeling that this was one of those things that I was thinking I was going to come back to and didn't wind up coming back to it. So let's see, our loop in our engine, yep, it's just calling zone manager update with 0. Okay, so interestingly enough, this bug is actually coming up because we actually depend on the time at this point. So for some reason I hadn't updated that, so let's go ahead and fix that now. So private, we're going to say previous time, and it's going to be a number equal to 0. And in our loop, we're going to say let delta equals performance.now. Performance.now basically gives us accuracy down to the millisecond. Actually, I think it's the microsecond. And so it's definitely the most accurate when it comes to timing, so it's definitely the one that we want to use. So we're going to say delta equals performance.now minus this dot previous time, and we want to just pass delta into both of these update calls. And then before the render, we want to say this dot previous time equals performance dot now. Okay, and let's just separate this out with some comments for now. Actually, let's perform just a little bit of cleanup here just to make this a little bit easier to understand what's going on here. So let's go ahead and say private update void and private render void. And we're going to take this code up to our previous time and put it in update. And we're going to take all of this code and put it in render. Get rid of some of these empty lines here. And now in our loop we can say this dot update, this dot render, and just clean that up a little bit. Okay. Let's go ahead and rebuild that. Okay. Run it. And it looks like something... Looks like we're getting some sort of weird animation here, but it's definitely not what we're looking for. So let's just take a look at our output here. So it looks like this is resetting correctly. So it looks like it's animating at the correct rate. So at least we know that's working. But the UVs, there's something seriously wrong with the UVs. So let's go ahead and take a look at Animated Sprite in our update loop and see what could possibly be going wrong with it. So I just want to take our simple vertice code and paste it here just one more time, just for reference. So this was using the minimums, this was using the minimum, then the maximum. These were both using the maximums. This was using maximum, then minimum, and then this was using both minimums. Okay, so those are correct. So it's quite possible that our frame UVs themselves are actually incorrect. Okay. I have a feeling that it has to do with these not coming through correctly. So let me just update this. Let me just spit these out. Say width / height. So what I'm going to do here is just output these values to the console so I can see what they are when we load. Oh, that's interesting. It actually seems to be working now. Okay, I probably had something cached. What on earth? Let's get rid of this console log. We know that's working. So 1 and 1. That is why our UVs are messed up. So at the time this load is done, this texture doesn't actually exist. So that means that I can't actually do this entire step here in load. I need to do it later than that. Technically, it means I'm going to have to do it when I receive a message about the asset being loaded. So what I'm thinking is I think I'm going to have to listen for this message that basically says this, hey, this asset's been loaded. So the animated sprite is going to need to implement iMessageHandler. Okay. And I'm just going to cut this from here, paste it into a better location, set that to public. Okay, so I copied this message code from the other class. Basically what I want is message dot, so basically what I want is if message, not menu bar, message dot code equals message asset loaded plus this dot material dot diffuse texture name. Then I can go ahead and perform all these actions. So you know what, let's go ahead and change this. Let's go ahead and throw this entire thing in a private method. We'll call this private calculate UVs. Okay. And then what that will do is it's just responsible for calculating those UVs. And then at this point I should just be able to say this.calculate UVs. And that should be it. Okay. One more thing, I'm actually going to need to subscribe to the message, so in the guess I could do it in I want to do it in the constructor. Let's go ahead and subscribe to the message here. So say message.subscribe, and I'm just going to copy that. And the handler will be this. Okay, so now whenever that asset loads, that's the time that we'll actually go ahead and generate the UVs. Okay. So let's just reload this. Ooh, looks like we have an error. Cannot read min of undefined. Okay. Let's pause this on caught exceptions and just refresh this real quick. So the frame UV is 1. Oh, that's not going to work because our texture is not actually loaded yet, but we're performing an update call. This is an interesting race condition. Okay, So let's go ahead and close that. So we're actually going to need to keep a flag in here to say if we've even loaded yet. So we'll say private asset loaded, and we'll define that to false. Okay, and so the update will check first to say, hey, if this dot asset loaded is not true, return straight away. Don't execute any of this code. And then in here, when we receive this, we'll have to say this dot asset loaded equals true. Let's rebuild that. So basically it'll say that we'll only run that update once we've received the asset. First this. Okay. It's still 1 and 1. Oh, okay. That's because let's see. It's likely because the material hasn't actually received it yet. So again, we have a interesting race condition. So I think the safest way to handle this is to create a new private asset width, and asset height. And let's default both of these to 2, just to make it explicit as to what's happening here. And let's replace text width with this dot asset width. This dot asset height. Get rid of these 2 things. Let's just replace these things here. We'll report what these are. And then when we're responding to this, we'll also set this dot asset height equals to actually asset equals message dot context as image asset, because we know that's going to be an image asset. So now we can say this dot asset height equals asset dot width, height. This dot asset width equals asset dot width. Now we should be good. Okay. Alright, so we're like 90% of the way there. But it looks like our last frame might be missing. So let's see, we've got a blank frame in here somewhere. And I'm not 100% sure where that's coming from. So it looks like so if we look back at our image, looks like this upward frame is actually what's missing. Actually, I don't think it is missing. I can't tell. Okay, so there's a couple things we need to change here to help ourselves debug a little bit. First off, the clear color. Let's go ahead and set this to be a slightly bluish color, just so that we can see things a little bit easier, distinguish it from the background a little bit. Okay, so the other thing is you'll notice that the actual sprite itself is transparent here, and here it's not, and that's because we don't have blending enabled. Okay, so there's a couple things that we need to actually perform here to enable the blending. So we need to say gl.enable and then gl.blend. Okay, and then we need to say gl.blend function, gl.source alpha, and gl.1 minus source alpha. And those things will actually allow us to have transparent textures. And you'll see now our little duck guy is showing up with over our transparent background. Cool. So we're still missing a frame here, so let's go ahead and fix that next. Okay, so if we look, I'm thinking the issue is probably going to be right here somewhere. Total width is greater than this. Ah, okay. This should be asset width instead of width. And there we go. So now we can see that our little duck is sort of flapping through the air, and the animation is looping exactly how we want it to loop. And so this actually kind of concludes what we're going to discuss here. I'm going to go ahead and cut this video off here because I know it's gone on kind of long, and I do apologize for that. But you know, sometimes you just run into things as you're sort of developing that you kind of can't get away from. So anyway, thank you guys so much for watching. If you haven't already, consider subscribing, and I'll see you guys in the next video, and I promise it will be a lot shorter and a lot simpler than this one. So see you guys next time.